You'll recall that in Python there are 5 scalar data types: the integers, the floats, the complex numbers, the Booleans, and the none data type. The first 3 of those, I would say they're numerical data types: the integers, the floats, and the complex numbers. And in the previous video, we saw how we could use numbers in Python to evaluate simple mathematical formulas. In this video, we're going to focus on the Booleans. And the Booleans are much more simple. Instead of being able to take on a wide array of values like the numerical data types, Booleans can only take on 2 values. But despite their simplicity, it's the Booleans that allow us to go from simple mathematical formulas to large algorithms. So they really enhance the power of our computer languages. Let's see how they work. So, as I mentioned, a Boolean is a data type that can take on 2 possible values. And in Python, those values are called true and false, and we capitalize true and false. There are several uses for Boolean data type. One is to just declare a simple Boolean variable that represents something that can only have one of 2 values, such as, for example, a switch can be either on or off. And so here I have declared a variable called switch is on and assigned it the value true. So the data type for switch is on is Boolean. We can also use Booleans to create simple Boolean expressions. In this case, I have a variable called isSpeeding, and I am assigning it the value on the right-hand side, which is a simple Boolean expression that takes a variable that is declared elsewhere called speed, and if it is greater than 65, then this Boolean expression on the right-hand side will evaluate to true, and otherwise it will evaluate to false. And so isSpeeding will have the value true, will be a Boolean data type, and will have the value true if speed is greater than 65 and false otherwise. Then we can combine simple Boolean expressions to create more complex or compound Boolean expressions. And here's an example of that. That is determining when it is safe for an airplane to take off. And the conditions for that is that the visibility should be at least 3 miles and the cloud height should be at least 1,000 feet. So those are 2 simple Boolean expressions: visibility greater than 3 and cloud height greater than 1,000. And we combine those 2 simple expressions using the AND keyword. So we are going to go into all of these components on how to construct a compound Boolean expression next. So simple Boolean expressions are pretty intuitive, and we're going to see here how to create them using comparison operators in Python. So this table shows all of the comparison operators on the right and their respective English phrases on the left. Here, A and B stand in for, say, 2 numbers. So if we wanted to evaluate whether the number A is equal to the number B, we would use the expression A equal B, or A double equals B. Notice that this is different from A equals B, which is an assignment of the value on the right-hand side, which is B, to a variable named A. That's different. Here, the double equals is saying that this simple expression will evaluate to true if A and B are the same, and to false otherwise. Now, the opposite of that would be A exclamation point equal B, or A not equal B. And this will evaluate to true when A is not equal to B, and to false when A is equal to B. So it's the complement of the double equals. We can also ask whether the A is less than B, and that is A less than symbol B, A greater than B, A less or equal to B. This will evaluate to true if A is less than B or A is equal to B. And A greater or equal to B will evaluate to true if A is greater than B or A is equal to B. Next, we will see how we can combine simple Boolean expressions to obtain compound Boolean expressions using the operations of Boolean arithmetic. Now, these are called Boolean arithmetic by analogy to the numerical arithmetic that we saw before, where we could combine, say, two numbers with an operator such as a plus or a minus or multiplied, etc., to obtain a third number. So, for example, 2 plus 3 equals 5. Here we have operators and or, and we can combine two Booleans, P and Q, to obtain a third Boolean. Here, these tables show us how these operators work. So this is the table, it's called the truth table, for the AND operator. And so because P and Q are Booleans, they can take on only two values. And so there are only 4 possibilities for P and Q. In the case of AND, P and Q will be true only when both P and Q are true. If either P or Q is false, then P and Q will be false. Those are these 3 values here in the lookup table. As for P or Q, it's kind of the opposite. P or Q will be true whenever at least one of P or Q is true. So there are 3 cases when P or Q evaluates to true, and only one case where it evaluates to false, and that is the case where both P and Q are false. Then there's one more keyword, that's the not keyword. And all that does is that it flips the value of P. So this is not an operator that combines 2, it's just changing the value of P. So if you say not P and P was true, then not P is false. And if P was false, then not P is true. See if you can solve this. What will the value of Z be after executing the following code? And the code is P is true, Q is false, so both of these are Boolean variables. And then it evaluates this compound Boolean expression involving P and Q and assigns the result to the variable Z. Okay, so what you have to do is to see what this will resolve to when we replace P is equal to true and Q is equal to false. I'll do it here. And I'll begin by just replacing the values P with true, so I'm just going to abbreviate that to a T. And Q replaced with false. And then I have parentheses, and then or, not, and then P was true. So the first thing that Python will do is it will resolve what is in the parentheses, and that is an AND operation with operands T and F. So look up in the truth table, and only resolves to true when both of these are true. So this will resolve to false. And I still have or not T. But not T is just flipping the value, so this is going to become false. So this not T becomes false. And if I look in the truth table for or, false or false is evaluating to false. So therefore, Z is going to be false.